Okay, last time we have the intercooler. We use water-cooled heat exchanger to absorb the heat coming from the low stage compressor going to the second stage. But before entering the second stage compressor, the superheated refrigerant coming from the low stage compressor change it to saturated vapor. Thereby the water coming from the cooling water is absorb the heat in the refrigerant side and then change superheated vapor to saturated before complete compression to the second stage or the higher stage compressor. That is by the use of intercooling with water-cooled heat exchanger. Okay, so we have two mediums, no? The refrigerant in your refrigeration system and the cooling medium, which is water, to absorb the heat coming from the refrigerant side. However, if you use only one compressor and solve it by standard vapor compression system, we have only one big capacity compressor, which in turn the combination of low stage compressor and high stage compressor, when we combine them together, the power coming from the single compressor by this system is much more greater than when we combine the power coming from the low stage and the high stage. It means that using intercooler, there will be power save. Okay, there will be a power save in compression or reduction of torque of compression per pounds of vapor. When we combine these two, notice that this point, point 2, using intercooler, water-cooled heat exchanger, will automatically go to the saturated vapor line before it will go to the second or higher stage compressor. However, using this one, point 1 going to point 2, going straight to discharge point 2 without any intercooling, notice that the rejected heat is much more greater than compared to this one, to this system using intercooler. Because if you use only one compressor, there is a isentropic constant line going there. This one, isentropic constant line going to this point. It means that there is a gap, or the area is reduced. The area of compression is reduced by this much using two small capacity compressor. It means that this area now, if you are going to use only one compressor, this shaded area bounded by this area 2, 3, 4, let's say consider this as your point X, is considered as your power save. Yes, power save. Again, if you are going to use only one compressor, one big compressor, then we have a straight line going there until it crosses pressure correspond to 40. However, by using intercooler, we have two small capacity compressor that make point 2 converted into saturated vapor before entering the second stage compressor, the higher stage compressor, for a complete compression of the refrigerant in the system. Thereby, the area which is supposed to be going there, straight going there to the point X, is reduced to from 3 to 4. So this shaded area is again is what we call the power save. And when we compute this, it is supposed to be equal to, or the power of compressor using only one big compressor is much more greater than when we combine the power of the low stage compressor and the high stage compressor. By computation, it must be this one. Okay, if there is no difference between the two computations, then your computation of power save is, or the computation using intercooler is wrong. There should be a power save by using this intercooler. Again, it is a intercooling with the use of water-cooled heat exchanger. Okay. Now, this system using water-cooled heat exchanger is, as I've said last time, it is considered closed system. Okay, closed system in the sense that the water coming from the cooling system does not mix direct to the medium coming from the refrigerant system. It's only absorbed the heat coming from the refrigerant side, absorbed by the cooling system, and reject it to the atmosphere. So again, we have two rejection of heat. The rejected heat coming from the intercooler, and again this is by the use of water-cooled heat exchanger, and the rejection of heat coming from your condenser. You can use a medium. It's either in a big capacity. You can use also cooling water. If it is not the capacity is not medium capacity, if the capacity is medium, then you can use high velocity air. Okay, so that is the system using a closed system water-cooled intercooler. Okay, let us proceed now to an open system intercooler. In an open intercooling procedure, open in the sense that the refrigerant itself will be the one who mix to the refrigerant flowing to the system. So the refrigerant on the high side, or the superheated vapor side, is later on mixed to the refrigerant coming from the saturated or liquid side, with of course with the same pressure, because you cannot combine high pressure and low pressure. So the next topic involving intercooler is intercooling with liquid refrigerant. Intercooling with liquid refrigerant is considered open system. So in your thermodynamics, once it is open, there will be a mixing of the medium, and at the same time there is a transfer of heat within the system. So mixing and transfer of heat are performed in a system. Okay, so this is your block diagram. Okay, Okay. Okay, we have the condenser, the evaporator, we have the open system intercooler. So you have your intercooler. You have your compressor A, which is the low stage compressor. We have compressor B, the high stage. Then we have, of course, this one is expansion devices also in constant enthalpy, but we have a float somewhere here. We have the expansion device, and then they're all liquid settle at the bottom. These are liquid because it has gravity, and it allows only vapor refrigerant to going up. So this line is not actually submerged in the liquid. It allows vapor refrigerant to suck in your high stage compressor. Okay, this is again at constant pressure. It is considered open system because the refrigerant coming from this side, which is superheated vapor, high pressure, high temperature, at low stage condition, going into your intercooler and mixed with the refrigerant. This is considered wet, coming from the high side, your condenser side. But then after this is a valve. It will of course reduce the pressure so that the pressure coming from the low stage compressor meet with the pressure coming from the condenser, reduced to again to the pressure coming from the low stage. Okay, so all of them, we have the what we call intercooling pressure, P intercooler. Okay, and all liquid settle at the bottom because of the gravity. The saturated vapor coming from this side, this is superheated. When wet mixture combined with superheated vapor, all of the liquid settle down, and it allows only saturated vapor to going up, sucked by the high stage compressor. So again, superheated vapor will once again change into saturated vapor. That is that's the first function of your intercooler before complete compression in your high stage compressor. Okay, and then at this portion, since all of these are liquid, the wet mixture once again changes into saturated liquid. And then it will pass again to expansion valve at constant entropy, once again change into wet mix at evaporator pressure, and you absorb heat here, heat added, so that wet mix change into saturated vapor again before it will pass to compressor A, or the low stage compressor. This one is again superheated vapor, high pressure, high temperature at high stage condition, and then there is a rejection of heat here, so that superheated vapor change into saturated liquid, and then cycle continues. So if we consider this as your point 1, this is your point 2, superheated vapor change saturated is point 3, and then point 3 to point 4, 0.45, 5 passes to expansion device at 6, and then it will go to the next expansion bulb going to evaporator to 7, and then after expansion device is your 0.8. Okay, so that is your block diagram as well as the change of phase of your refrigerant in the system. Note that there will be no rejection of heat along this or within this intercooler because it is considered adiabatically sealed. Adiabatically sealed means that there will be no heat going into the intercooler, neither no heat going out to the system. There will be an exchange of heat as well as mixing of medium coming from this side to this side, and there is an exchange of heat coming from this side also going to this side, but there will be no rejection of heat, unlike to in our first intercooler system using water cooled. So in this system we have only one heat rejected, and it is coming from your condenser. Okay, so we have all the necessary points there, and we are going to proceed to your pH diagram.